Good afternoon, welcome back to the Workbench. Welcome back to this telephone here. I'm back here for round 2 with this thing, because I didn't fix it fully last time. I did fix up the cord, and as we saw the plug was the issue, even though I did cut some off the internal part and had to rewire it, but anyway, it works now. At least it has a connection to the line, and if I pick it up I hear a dial tone. Everything seems to be okay. And I can dial out and I can make calls with it, and it does work. The only problem is it doesn't ring. Makes no sound when the thing rings, and I'm guessing what should be a pair of LEDs under this sort of translucent sort of bezel. I wouldn't say opaque, but opaque means you can't see through it at all. But I'm guessing there should be some LEDs under here which flash along with the ringer. This LED here is just for the speakerphone feature. So yeah, no lights flash. No sound happens when there's a incoming ring signal on the line, and yeah, this doesn't fully work yet. So I'm back again to see if I can figure out what's wrong with that, and hopefully fix it and actually get the thing fully working. So, and that would be great. Anyway, so I did some research into it, and I'll show you my findings. I went through the ICs in it. So there are 3 ICs that I saw last time. And the first one is this, the HT9215D, the Holtek HT9215D. Fortunately, there's not actually anything particularly useful here on the internet for that particular number. All I really found is just this like pin list and description here. You know, it says the HT9215D integrated circuit of PC dialing is widely used in all kinds of phones. It is pinned in DIP packages with 24 pins. Pin functions and data are listed in Table 1. And yeah, we've just got like these fully in Chinese lists that are not really particularly helpful. That's basically all I could find. So, but however, I did find this one. I did find the datasheet for an HT9214, which I guess is basically the same thing, but maybe with less features. Like, I don't know, I haven't gone extensively through the datasheet to find out what the difference might be. I think possibly the call timer function is not in this one. So, because it does mention an LCD for showing the number that you're dialing, but that's it. Anyway. So that's what I thought. I thought that chip would be to do with the dialing and making the DTMF tones. And that basically is what it is. The block diagram there and all the pin outs. But if you go down to, like, you know, there's a lot of data here and waveforms and everything, but we go to like a basic thing here. That's sideways. How can I rotate this? Let's have a look. There we go. So that's a bit more useful. So you can see the basic idea. You know, you've got the line comes in through a bridge rectifier. We've got a hook switch and some transistors, look like voltage regulator or some sort of thing. And or maybe this is the voltage regulator here. We've got a Zener diode. We've got some other stuff. Various things. I don't know exactly how all this works because I don't know much about telephone stuff, but you know, you've obviously got a keypad here, and speech network. I'm pretty sure is the to do with the you know, the processor that does the actual audio, and this has got a piezo speaker for, I think, keypad tones. When you press the buttons, it'll make a noise. That's got nothing to do with the ringer. Yeah, if we go back up to the pin list. Yeah, KT, ketone output pin. Outputs a 1.2 kHz tone when any keys are pressed in the pulse mode, or when the function keys are pressed in the DTMF mode. So yeah, that's got nothing to do with the ringer. That's just a output for when feedback for pressing keys on the keypad and whatever. So yeah, so this thing basically handles the keypad, it handles the dialing, and it does all that stuff, and it has an LCD here. Oh, sorry, that's turn around here. So we got a LCD driver there. We've got the audio interface here. I think it's got something to do with that, and then switches for settings here. Yeah, you're using pulse dialing, tone dialing, whatever. Yeah, and then a keypad input. So that's all doing that part. That's not really anything to do with the ringing. And then of course we have this here. let's get back up to the top. So this is the main sort of chip that actually does all the audio stuff. And this is the Holtek, the Motorola MC33215. And yeah, so it's got all the like stuff here, and it does the speakerphone and everything. So basically, we got all the points there of what it does. But yeah, this does all the main sort of audio stuff. And if you go down, they've got a lot of data on this. It's quite fascinating. But there's like a example test circuit. But here's the typical application circuit here. So again, we have, this is the big block diagram of this chip, and then over here we've got the dialer and the keypad. So this will be again the Holtek chip, the 9215, which interfaces with this one. I don't know why exactly. Maybe to do with the mute function. I think it can send the mute information. But yeah, I mean, this has like a bunch of stuff. It's got, this here is a loudspeaker for, whoops, this one's like loudspeaker driver for the speakerphone. That's the driver for the earpiece and the handset. And then you've got two microphones. This one, B mic, I think is bass mic, so that's for when you're using speakerphone, and then H is I think handset mic, so that's for the other one. So yeah, it's got like two speaker outputs, two microphone inputs, got a bunch of other like support capacitors and things for oscillators and whatever, and all that kind of stuff. And then you've got the DTMF input from the dialer chip. Oh yeah, and the speakerphone button for some reason is handled by the dialer chip, and then that sends a signal here to tell it to switch to speakerphone mode. I don't know why that seems strange. You'd think like the main chip would handle that, but whatever. And yeah, we have like the line input here, bridge rectifier, and again a similar sort of circuit with these two transistors. But yeah, anyway, and then we've got like a Zener for clamping the voltage, and obviously it has its own power supply inbuilt to power itself. So yeah, that again, but this only does the audio side. This is just handling the speech and the stuff. We got the dialer as a separate chip, and that leaves us basically the ringer is not part of this chip either. Which brings us to the third chip, the last one, the little 8-pin chip up in the corner, which I mistakenly identify as an BA8205, but I misread the marking. It's actually an 8205, and guess what? This is a ringer chip, but it's basically all it does. Yeah, this is half in Japanese, but I think, yeah, I'm not sure. I think it's Japanese. Anyway, apologies if it's not, but yeah, this basically, I think it's just a little chip that has two oscillators in it. Low frequency and high frequency oscillator. It has an amplifier output to a speaker thing, and yeah, we've got a power supply inbuilt, and it powers itself here, and there's a example circuit down here, and this is what I'm interested in because it looks like this chip looks like this chip is solely dedicated to the ringing function, and obviously that's what doesn't work. So that's what I want to look at, is this particular chip here. So it's quite a simple little thing. We've got the line input here. It goes through a large high voltage capacitor. Well, not large, 1 microfarad, but fairly large for a film capacitor. And then we've got a current limiting resistor. We've got another bridge rectifier again. And then we've got a clamping Zener. This is, that's 36 volts. This is the max voltage for this is 40. And we've got a filter cap, and then we've got like these capacitors and resistors here for the two different oscillator circuits. This one here, RSL, and pin 2, what does it say? That's RSL power supply with hysteresis. So I think that's kind of like maybe a delay from when it gets the ring signal to when it starts ringing, or something like that. So it's going to be a startup thing. Possibly. I mean, I don't know what it says because it's all in Japanese or something. So, yeah, I'll have to sort of maybe try to translate that and see exactly what it says. But anyway, not that that's probably that complicated. But yeah, and then we've got like an output here on pin 8 that drives the speaker, or the piezo one. Really, that's what that symbol is, a piezo speaker, and that's what's in the bottom of the telephone. Anyway, so. Yeah, so anyway, that's that chip up there in the corner there, that little 8-pin one. So this is the one I'm going to focus on, because I guess that's potentially where a fault, if any, because this is the main chip that does all the audio, and that works fine. When I pick up the phone it works, and I put it in speakerphone it works, and that obviously this chip's working because the LCD works and I can dial out with it. So that's all fine, we don't worry about that. It's more like this side here And there's that big capacitor, probably. This big red one. You know, the high voltage one. And then, yeah, over here is the little ringer chip. And again, there's kind of like mark of paint or something on it, obscured the 8, and I thought it was a 3. But yeah, I mean, it's kind of easy to see. We got like 2 bridge rectifiers with 4 diodes, so one of these probably feeds the main chip, and this one, I'm guessing over here, probably feeds this chip. So, and this one should have this capacitor in line with it. At least going by the example schematic. So this chip doesn't seem to need that capacitor, and I guess, again, not with fully understanding how these work, I think, and this looks like what, a VDR for clamping voltage spikes or something, probably? I think so. It is marked V1, so yeah, I imagine that's for clamping voltages and stuff, in case, you know, there's a spike on the line due to a lightning strike nearby or something. But yeah, anyway, this chip here is what I'm interested in. This, I'm guessing, is that it's bridge rectifier and possibly after that capacitor. And then that looks like it's supply filtering cap. So for example, if that was open circuit or something, the voltage may never get high enough to actually power it. We've got the Zener diode here. Again, if that was short circuit or something, we could have a problem. Well, the chip itself could be bad, or like one of these, something to do with the oscillator circuit. I don't know how critical it is. If there's no, you know, if one of these caps went bad or something, short or open, would the oscillator still work? I don't know. Would it cause the whole chip to fail? And we've got these switches here which switch between like different volumes of the ringer and different pitches, I think. So again, you know, maybe if the switches were bad, open circuit or dirty or something, it could be a problem. And then these 2 wires here, the orange and red ones, go off to the little ringer, which is this piezo disc here mounted to the bottom of the phone. So yeah, it's quite a simple circuit, as you can see from the schematic, but you know, yeah, just going back to that for a moment, and I'm going to theorize about what I hypothesize, I suppose is really the right word, but yeah, so looking at this schematic here, and I'm just thinking what could go wrong with it basically to stop working, because it's a very simple, you know, very simple schematic. I mean, we have the line input, we know that works because I fixed the cord. We do have that, so you know, I'm thinking you could have an open circuit capacitor, open circuit resistor, whatever. But yeah, I'm thinking, I guess this capacitor here is to block the DC, because normally the phone line has DC on it to power stuff, and then you get a superimposed AC signal on top of that for the ring signal, as far as I know. So this would block the DC, meaning this circuit would not be functional normally. But when you get that AC ring signal, that will pass through this capacitor, and it will be rectified by this diode bridge here. It'll be clamped by this Zener and fill up this capacitor, and then this thing will start. So I'm not sure if the ring signal comes in bursts from the telephone line or not. I'm guessing it probably does, but again, I have limited knowledge in how this actually all works, but going by how this circuit is laid out, I can only imagine that would be how it would function. So I guess you get probably bursts of AC that come in here, and as they fill up this cap, this will start running, and we got the 2 oscillators will start oscillating and making this ringing sound, which I guess is, you know, based on traditional old style telephones that literally had 2 bells in them, metal bells that were hit by a I don't know, a clapper or striker or whatever you call it thing, and you'd have 2 different bells of 2 different tones, and they'd both go at the same time, and you know, so this is kind of the same thing. We got two separate oscillators with 2 different pitches that obviously mix together to make a clear ringing sound that's easily discernible. But yeah, so basically I think, you know, a failure of some of these components, this cap, this Zener diode, this capacitor here, maybe the chip itself. So basically, so I don't waste a whole lot of money rigging myself, calling myself up and rigging myself and testing it. I don't have like a circuit to generate a ring signal to test the circuit with. I'm sure it'd be possible to make one, but I don't think I need to. I just think I'll, you know, probe all these components and just see if any are open or shorted or something. And it may be quite simple, or maybe the chip has just failed. You know, that's entirely possible as well. Maybe this Zener went open circuit and then this thing got blown up with a over voltage, you know, who knows. That could also be possible as well, or maybe it just failed due to old age, I don't know. It's quite strange. Obviously, you know, this thing was thrown out. This phone was thrown out in a bin where I found it years and years ago, a long time ago really. So yeah, who knows, maybe there was a lightning storm and it failed after that and the owner just threw it away. I don't know. Could be a lot of things, I guess, so we don't know. Did it fail by itself? Was it caused by something else? I don't know. Strange that this plug had been faulty as well. But there we go. So now I've got some ideas of where to look. I can start probing around and testing components and focusing on this circuit here. Okay, so this is interesting. Yeah, I've been probing around a little bit and trying to figure out what connects to what, and I've found some things and been confused about some others. So if we have a look back here at the phone, we've got two sort of bridge rectifiers done with discrete diodes, and we've got this first one here, the center point of which connects to both of these incoming line wires, so I'm guessing this will be the bridge that goes direct to the main chip here. We got that VDR across the output of the bridge, so the line comes in, gets rectified, goes to this VDR, and then goes to the circuitry and inputs and to this thing. This capacitor then connects one side of capacitor, this input leg here goes to this red wire, and then I'm guessing the output goes to some part of the circuit as it shows in the schematic, or it should go to the bridge really, and then this bridge, you know, the output of this bridge should go to this filter cap and this Zener, which is, you know, hidden between the chip there. You can just see it, that little red one. The problem is it's confusing. The Zener and this capacitor are definitely in parallel, and they do connect to the pins 1 and 5 on the chip, which are the supply pins, and that makes sense. But I can't get a sensible reading directly from this diode bridge to the actual thing. Yes, there is a resistor, or there should be one in series somewhere, but I can't find it. I don't think there's anything surface mount on here, but I might have to pull it out. But yeah, I mean, we got that capacitor here, we got this resistor, and then we got the bridge. The bridge, like, I can't find a direct connection from the left side of the bridge to the cap or resistor, and I can't find a direct connection from the right side of the bridge to the Zener or the cap on this side. So this resistor here, unless they've split it and had two resistors, one on each side for some bizarre reason, but you know, there should be a direct connection either on this side or this side, depending on which side they've put that resistor on, and I can't see a 6.2k resistor there. I can see a 6.8k, I think, resistor 48. But yeah, it's a bit odd. I think it is. Let's see. This one here, R48. That's blue, grey, yellow. So yeah, 6, 8, and then yellow is 3. No, that would be 68k, wouldn't it? So yeah, that's probably not it. There is one down there, sorry, behind the VDR. I don't know how well you can see that. You can't see it at all. This one here, I think that's yeah, blue, grey, red, so that would be 6.8k, so that could be the one I'm looking for. But I'm pretty sure I probed to that one and nothing made sense. I'll try it again and just see. But yeah, who knows? Maybe that resistor is open circuit or something. I don't know. It's strange. I wasn't sure. Maybe I got the wrong one. But so that resistor should go to one of these. Okay, no, it does. Yep. Okay, I just wasn't probing correctly the first time. Yeah, so it goes to the two diodes in the middle. So that makes sense, and that resistor should, the other side of this resistor, sorry, you know, you can't really see it, but the other side of that resistor should go to that big red cap, which is hard to probe because one of its pins is really closely mounted to the board. It's very hard to probe onto, but let's see. Oh yep, there we go. So yeah, that capacitor, so the red wire comes in, goes to that cap, and then connects to that resistor, which goes to the bridge there. The other side, I suppose the green should just go directly to the other side of the bridge, yep, which is here. That is correct, okay. I know, I'm sorry you can't see where I'm probing, but It's really hard to get the camera up in that position, I don't think. But let's see, green input wire to like this diode here on the outside. Which means that this one, the output, should all be up this end. So I think, should these all be connected together? Or, no, not all of them, but... maybe the two. Yeah, no, these two should be connected together. They are. So that would be like D1 and D2 in the schematic. And then that should go across to this capacitor here. But we get 700 millivolts instead of a direct connection, which is, that's what's odd. Yeah, I don't know where that, and it's very precise too. I mean, it could just be another current limiting resistor or something. I don't know. Maybe this R47 or whatever next to that other one. No, it's connected, but it's not direct. Yeah, that's what's strange. I don't know why the output of that bridge doesn't connect directly to that cap, which it should. And maybe that's the fault. Maybe that's what's wrong with it. I don't know. Yeah, or could it be something to do with that switch on the side? We got ringer off, low and high, but I think that just affects the oscillators, I think. Maybe if I change that, let's change that to a different setting. Let's turn it off completely. The upper switch is the yeah, so it's only this middle switch here that affects the ringer. That's the tone pulse dialing switch, so that would affect the dialer chip, I guess, and this affects the tone, either high or low or off, and this one in the back is just the volume for the speakerphone. So yeah, so what if I change that switch setting? Do I get a different reading here? No, still exactly 700 millivolts. But again, I mean, that's not super high, like it should still work, so... but I don't know where that's coming from, because it should be a direct connection. I guess it's time to take this board out and just have a look and see if there's anything odd under there. Yeah, it's very strange. Because it makes sense otherwise, it follows this example schematic otherwise. Okay, the mystery is solved, I think, at least partially. At least the mystery of where that voltage drop was coming from. So yeah, I looked at the wiring on this board here, and yeah, the output of these diodes, on the positive output side, the cathodes there, those don't go directly to that capacitor, they go off down the board here to this ribbon cable, which goes all the way up to this other board with the keypad on it, and makes its way down to the front here, where there's a couple of LEDs connected in parallel. You can see these black and red wires here connecting them together, and there's hot glue. So yeah, we've got like 2 LEDs behind this here. Sorry, let's get this in shot. Yeah, so this little lens, whatever, has got 2 red LEDs behind it. They're connected in parallel, it would appear, and then they're in series with the incoming signal that comes out of these diodes here. That's the ring signal after it's filtered through this cap and everything. So yeah, so the VCC supply for this chip actually goes through these LEDs. So yeah, and that's why it's 700 millivolt drop, because you've got 2 red LEDs in parallel, I suppose. So that makes sense now. So yeah, and the rest of the circuit all seems to be logical going by the schematic. So yeah, I suppose it's a possibility that if these LEDs were faulty, that could be a cause of the issue. I also thought possibly, maybe I can just power this circuit, with like, I don't know, a voltage, DC voltage or something, maybe 20 volts or something. The data sheet does say like typical 20 volt, I think, for VCC. So I could try externally powering this circuit and just seeing if it runs. That would prove, whether it's the input or the other bit. I suspect it's still maybe on this cap being open circuit or something. But yeah, the bridge rectifier, the diodes all seem fine. That resistor is fine. Actually, I didn't check the resistor. I checked to see if it was connected on both ends. I haven't actually checked the resistor is okay. I probably should do that. Let's do that now. Why not? Let's see. 20k. It'd be funny if the resistor was open circuit. That would explain it. But yeah, let's just see. This is actually like 6.8k. Yeah, no, that's fine. So yeah, that resistor's not bad. The diodes all seem fine there. The Zener is not shorted, I don't believe. Otherwise I'd get a short circuit across here, but I'll check it just in case. Yeah, it's got a forward voltage drop on one direction, and it should have nothing on the other direction, but yeah, as you'd expect, it's probably like a 36 volt Zener, as they say. So yeah, I think, and the chip's not shorted obviously, because that's measuring across the Zener, measures directly across the supply pins of the chip. So yeah, I'm thinking, yeah, either those LEDs are going bad, maybe they're breaking down under load, or maybe they're worn out, they're not passing enough current to actually run the circuit. Something weird like that. I can try just jumpering them out. I'll just put a wire directly from the output of this to the input of that and just bridge them out. Maybe that'll make a difference. Oh yeah, this cap, I could take this cap out and check it to make sure it's not open circuit. Other than that, it could just be the chip itself is bad or something there, but yeah, there's not really much else to it. Or this piezo thing could be bad, but again, the lights don't flash, so there's two LEDs in the back of there that should flash when it rings. So the fact that those don't flash at all indicates that there's no current going through them. So the circuit would be completed if there's current flowing through the LEDs, through the bridge, through the chip, back to ground or whatever, back to the other side of the line. That kind of implies we've got an open circuit somewhere, something in this chain. So could be that capacitor there, could be the chip itself, could be the LEDs. I don't think it would be a problem with this, because again, if this piezo thing wasn't working, the lights should still flash, but we just wouldn't hear anything. So my hypothesis is, I guess, yeah, either this cap here is open circuit, the chip is open circuit, or these LEDs are, well, they obviously don't measure open circuit in circuit unpowered, but maybe, yeah, maybe they're not passing enough current to actually run this chip. Alright, it seems like we're getting somewhere. Yeah, I just connect directly to the negative output of the bridge and the positive side of that Zener diode. Easiest to clip onto there, and I've set my bench supply to 20 volts, which is what it says on the schematic here. If we check here, where was it? Where's my mouse gone? There we go. Okay, where was it? Up here, I think. Yeah, so we've got this here. I mean, I don't know, this is confusing. I think we got like haven't translated the Japanese, but we got VSI or VSL, which is typical 20 volts, it says, and then we got VSUS, which I guess is V sustain. So I'm guessing like the circuit will start ringing at 20 volts and keep ringing so long as the voltage doesn't drop below 12 or so. And that's when it will turn back off again. So yeah, I think that's how it works. So yeah, I've just connected my positive probe to this pin 1. Basically the negative is like to the anodes of these diodes here, and if I switch the power supply on, it makes a ringing noise, doesn't it? I think you can hear that. Yep, my level meter goes up, so yeah, that seems to work. I take it down, yeah, it'll stop around 12 volts and it won't start until it gets back up to 20. So yeah, it works, obviously, the ringer works, the circuit works. Now of course this is bypassing those LEDs and it's bypassing that capacitor there as well. There's a 20 volts DC directly into the chip, which is what it would expect after that filter and Zener and everything. So interestingly, when that is on, we do get like just a constant ringing sound, which does imply that like the ringtone signal from the line would be in fact, you know, coming in bursts, which I don't know, I guess that's how it works. So yeah, as long as it gets power it will ring, so that signal must come and go in bursts, because normally you get it going like, you know, that's what a phone normally sounds like. You get the, well, it's like anyway, whatever. So our issue is probably something else. So yeah, either this cap is bad or these LEDs are bad. I guess it's going to be one of those two, I think, because that's really the only thing else that's in line with the VCC supply to that chip, and if the chip works fine powered from an external source, then yeah, it's got to be one of those two things. Interestingly, the plot thickens or something. Anyway, I pulled this capacitor out because it was the easier thing to do than trying to muck around with the LEDs, considering they're all hot glued in and everything. And I mean, they don't read open circuit, so I figured, maybe what's more likely, the thing that reads okay or the thing that we can't test and is easy to get out. So I pulled the capacitor. It does match up with the example schematic, 105k 250 volts. So yeah, there's a bit of glue on it when it was stuck in with that awful brown glue that goes all funny. Yeah, but anyway, 105, so yeah, that should be 1 microfarad, which is what it says in 250 volts and what it says on the schematic there. Exactly the same thing, as you can see. 1 microfarad, 250 volts. Obviously it has to be that large to pass enough current for the circuit to work. So yeah, there we go. It is what it says, so it's the correct one. But I did notice, the way they've bodged it in on here, there's no actual proper space for this, and they just had it sort of stuck over here like this between these two things, and one pad connected to one of these things for C47, the other bit connected to the anode of Z5, which is obviously a xenodiode that's not populated. So I don't know, maybe there was some idea of using a xena instead of a cap. But obviously that didn't work, so they've bodged this in. And yeah, I wonder if that could be the potentially the cause of the problem, because what is interesting is if one looks up close at these pins on this capacitor here, you'll notice it's like they've been wrenched sideways, and you can see there's like, a mark in the as you can see on that side, and it's very hard to get the camera up. I could take a close-up photo and put it in, but definitely on this side you can see where the leg has been bent over so far it's cracked the body, and potentially, moisture could have gotten there and damaged it or something. I don't know. But yes, the interesting part is if we put this on the capacitor meter. So I've got this here, and I've set this to microfarads, 100 microfarads, so we got 99.99, so we should see 1 point, something there on the display when I hook this up. But we don't. We only see 0.07. And if I turn this to nanofarads, we get 76.4 nanofarads. Yeah, that's kind of like 10, 12, 13 times lower than it should be. So it's almost 100 nanofarads, but it should be 1 microfarad, which would be 10 times that. So yeah, it's bad. This cap is bad. I don't know why. Is it manufacturing problem where they've cranked the leads over so hard that they've broken it internally, or they've set it up for moisture to get in and corrode the terminals and it failed that way, or did it see an overvoltage spike on the line due to some environmental issue and it failed because of that. But either way, this is either, well, it's not open circuit, it does measure 70 nanofarads, but that's far less than what it should be, and obviously it just can't pass enough current to actually work, and the circuit doesn't work. So we know the circuit works because on the power supply it works fine, and this cap is not measuring good, so I'm going to have to find you one of these. Now the only problem is I don't know if I have any. And it's Sunday, so again I can't just go to the shop up the road, who probably would have some, and yeah, maybe I have to go to J-Car. I don't know if they have any. They should do, but they're probably like $5 each or something ridiculous. Yeah, I probably have some lying around, but we'll see. Anyway, that's it, I guess. That should be the problem, unless the LEDs are also bad, but yeah, I mean, they don't measure bad, so anyway, this definitely is bad. We know that for a fact, because it's, yeah, far less than what it should be. So there we go. That seems to be the, the smoking gun, the something. Anyway, this is not in good health for some reason, and that's probably why it's not working. So we need to replace that for a start, and then see what happens. Then we can test it again. So I'll need to find another capacitor that's suitable. Okay, so I went through my capacitor stocks and I found some which look suitable, some which aren't, and yeah, anyway, I had a bunch here that I got from JCar recently. These are, well, they're not really suitable. They're 1.5 microfarad and they're 100 volts, so the voltage rating's too low, the capacitance is a bit too high. They are probably not good for this. Got these ones here, X2 capacitors, decent quality ones, proper, proper ones, rated with proper certifications and everything, but they're 0.47 microfarad, so I'd have to cram like 2 of those in there somehow, which I don't know if that would fit. I suppose it would actually be possible, but yeah. Not necessarily the best option. Got some really old, super old ones with stripes on them, before they actually printed numbers on them. I don't know where this is from, like gosh, I don't actually know, 60s or something maybe? I'm not sure. I don't know how old these are, I don't know if they'd be any good. I don't know if any of them would be the right value or voltage or anything. They look like they're not in great condition, so who knows. And then I found these, 1.5 microfarad, 250 volts. These are all brand new. These look fine, but of course the capacitance is a bit higher, so my issue with that is maybe it would pass too much current for the circuit. I don't know. I would be concerned that this would potentially cause damage because there'd be too much current flowing. I don't know, the higher the capacitance, the more current will go through it because the reactance will be lower, all that kind of thing. So I don't know, but we did find these, which are a bit old, but they are the correct rating. So these are in fact exactly 1 microfarad and they are 250 volts. So they're very similar. They're also pretty much exactly the same size. Slightly bigger because they're a bit older, but yeah, I don't know. Maybe I can use one of these, hopefully. I don't know where these came from. They are probably, I think they were ones that I inherited from my great uncle about 10 years ago now. So yeah, but these look like they're brand new, old stock, never been used. So that one of these might work. I guess I can test it on here at least and see see if the value is correct. But I mean, I would like to do like a leakage test on that at full voltage and just see if it was actually not going to break down or something under load. But if we do a test on here, yeah, I mean we get 0.9, which is more like it, more like what we want. That's a little bit low, but again these are pretty old and the tolerance is what does it say? Well, actually this could be a temperature coefficient thing. It's got minus 45 degrees, plus 125 degrees, W, K, G? Not sure what that is. Maybe it's saying that, oh yeah, we've got 1.0 plus minus 10. Yeah, so 10%, I mean 0.9 is within 10% of 1, so yeah, it's just in spec. I guess the other stuff's probably a temperature coefficient. Whoops, the camera's not in the right place. Yeah, you can see there where it says like, yeah, I'm not sure, minus 45 degrees, plus 125 degrees, something watts per kilogram? I don't know. Not sure about Tempcos or whatever on film caps. No idea. But yeah, I mean that one at least seems to be basically in spec. Yeah, I'll just test the other ones maybe. See if there's any difference. Whoops. It looks like a couple of these have been used before, so I'd rather use one of the unused ones, but let's just see what the variation is. There we go, see that one's 0.95, that's a little better. Oops, that's just gone up because the lead fell off, but yeah, I mean that's okay. That's only 5% out. But this one seems to have the least damage. I prefer this one, the leads. Again, we have the same issue with this one. The leads have been bent a little bit and caused a little bit of cracking, and the two that are used definitely have that issue. And again, whether that contributes to the failure or something, I'm not sure. But yeah, oh, there we go, that one's 0.98. So that one's pretty good. That one's only 2% out. And what's this old one here? Yeah, 0.96, so that's pretty good too. They're all definitely within spec for capacitance, but I don't know what the leakage current would be if they, you know, you want to issue with, like, you don't want voltage breakdown or something. Anyway, but yeah, I'd love to test this, but I can't do a full thing on it. But yeah, I might just put this in and we'll just test it at least and see if it works, because that's easiest. I got it to hand here. I don't know what JCar would have. I'm sure they would have ones like this, but again, they're probably like $5 or something silly. So, in fact, let's just look that up and just see, just for fun. Let's find out. Let's find out how bad their prices are. Well, you know, they're not terrible, but for some of their stuff, they're actually pretty good. For some of their stuff, they're terrible. It just seems to be hit or miss whether or not they have good prices or not. Anyway, oh whoops, I've got to change to here. Okay, so yeah, we got that there. Let's see. They've changed the side around a lot. I don't know. Let's go 1 microfarad. Now we got a 100 volt, but we want a 250. They may not even have a 250. Oh yeah, they do. Yeah, and I was correct. They've only got like high voltage. Yeah, crossover cap. 1 microfarad, 250 volts for, yeah, $4.70. So yeah, I was right. It was about $5 actually. Which I guess, you know, for a crossover, it's probably designed for pretty high power. So that's probably why it's more expensive. But yeah, well, let's just put that one in I've got and just see what happens. I might need to clean the legs up a little bit. They're a bit tarnished, a bit old. But I will carefully bend the leads in a way that will not rip them half out of the side of the body like this one has been. But it could have just been subject to voltage spikes or something and broke down over time. I think those things do sort of do that, you know, like I see Big Clive does a lot of videos like that, where those X2 caps or whatever, where they have a capacitive dropper circuit to power a little night light or some small power thing from the mains, and eventually over time these caps degrade, the capacitance goes down and they can't supply enough current to do anything, which I guess is pretty much what's happened here. Alright, yeah, so a quick rub with a Scotch-Brite pad, and these leads are looking really nice and shiny. They were barely tarnished at all, really, and considering how old this thing probably is, well, that's pretty good. It sort of says a testament to its quality, so hopefully it should be good in other respects. I shall install this now, and I'll be sure to bend the component lead in a way that doesn't cause it damage. So if I look at the pins here, because this one's actually slightly longer, it almost fits right in, but that would be with bending it out a little bit. So yeah, I'm going to bend it a little bit, but I'm going to do it in a better way than they did, if I can find my pliers. Yeah, so, you know, instead of just bending it directly over, you want to bend, you want to take it at some point just below that, and you want to bend it like this, and so that the bend is, you know, oh, come on, focus. Yeah, you want to bend it like that so that the lead is not bent at the body of the component. This one actually already has cracked a little bit. You can see it was actually already like that, but yeah, this is the one that looks in the best condition. You can't see a hole by the leg, so it's probably fine. But anyway, if it fails again, I can always just replace it with another one. But yeah, because the body is longer, it doesn't really require much there, so I've just sort of cranked that out a little bit. Yeah, so that should work just fine. I have to clean the holes of the board though, of course, because they're still full of solder. But we should be able to get that. It's a kind of a pain working on this thing because of how everything's connected with wires and everything, obviously, but it is possible. Let's see if I can suck the old solder out. That will be the fun part. Let's see. Oops. And everything falls over again, as it is wont to do. Okay. Put some fresh solder on the 2 points where the thing is, where the capacitor goes. And then I'll try suck that off with this here. Sorry you can't see it. There we go. That's that one done. And this one's done. Should be. Oops. That wasn't properly in the way. Yep, there we go. Nice and easy, because single-sided boards are nice to work on. Right. Flip everything back around again. Hopefully you don't rip all the wires off by the end of this. That's a good point, you know, if you're working on something like this and it stops working or the fault gets worse after you've done it, just make sure none of the wires have fallen off. Okay, so now... Oh, these holes too small. I think the holes might actually be too small. Oh, that's annoying. Let's see. This capacitor has bigger leads than the old one. I may actually need to enlarge these with a drill. Okay, small drill bit and a handheld little pin vise. Let's just enlarge these holes a bit. They're already basically almost the right size, but just a little bit rough too. I think it's a cheap phenolic board, and they've just punched the holes instead of drilling them, possibly. So they're a bit rough. Right. So there we go. That should solve that problem. Right. So now this should actually fit. Should. Let's see. Actually, you know what? I'll get rid of that glue as well if I can, because that's just annoying and weird anyway. There we go, a little bit of glue. Just removed it from the board. I don't like that stuff. It goes conductive over time and weird sometimes and corrosive and stuff. I can't see anywhere else, to be honest. They've only used it on the cap. It's everything else is just hot glue. Anyway, that should fit in the holes now. And it does. Now, I don't think this needs to be super low to the board, honestly. Got a couple of inductors here. But yeah, I mean, I think there's plenty of clearance, honestly. This is only slightly higher than that one, so I don't think that's going to be an issue in terms of that at all. So yeah, let's just solder that in. Is my soldering iron a bit too low? Yeah, it is actually. Let's just turn that up a little bit. Anyway. I think that cap has got a bit of thermal mass actually, because of how big it is. It's got some pretty thick leads too. Interesting. Alright, there we go. So that's in there. Now I just got to put the thing back together, and then what? Then I just have to give it an actual test. So let's see if I can get these back in. I see all the little all the little thingies that go on these switches have decided to fall down the side of the case. These little kind of actuator things. So I've got to line those up with everything now. Let me just push all those switches up to the top to get them all lined in. Yeah. It's a little fiddly, but there we go. Okay, that looks correct. Now I just need to put all the screws back in. I got the phone back together, obviously not put all the screws in yet, and here's the bad capacitor still hanging around for some reason. Right, we got one screw in, I got the thing all plugged back in and everything, and well, I haven't plugged it into the line yet, but I will about to do so, and we may see these lights flash. I don't know, my other telephone does that when I plug it in. It's just a basic one, kind of like this, but without the display and everything, and without speakerphone. But yeah, it's got a light that flashes when you plug it in, and when it rings. But yeah, I'll just try and plug this in with my left hand off camera, and if we see anything there, no, but yeah, I don't know if that's supposed to or not. Again, that's in series with the ring signal, so maybe nothing would happen, but you might get a brief current through that capacitor as it charges up from DC rather than whatever. Anyway, okay, but if I press this, I can show you that this works. So this is the speakerphone. Yeah, so you should be able to hear that. The dial tone does work. Obviously I can't use this, it's too quiet to work on the microphone, but that does work. The button for this is a bit crusty, so maybe that's something I'll need to replace at some point. It's one of those little basic tactile switches that seem to go all tarnished and weird after some time, so it's just easiest to replace them. So I might have to do that eventually, but yeah, I mean, see, I press it a bit and it doesn't work, but if I push it really hard it works. Anyway, so if I for example, well, yeah, I mean, if I turn this on, I can go like, I can dial a thing, and you know, you see. Anyway, but what I want to do is actually test to see if it rings. I know that it can ring out and I can talk and everything, so I'll just call it on my cell phone and we'll see if it works this time. Because last time I did this, obviously we heard nothing. And yeah, we should hear this actually ring this time, and yeah, this light here should flash. I think I saw it flash when I pressed the speakerphone thing a bit, so that's interesting. Anyway, let's see. There we go, I'm dialing. Yeah. Yeah, now I'm hanging up. So there we go, it works now. It does actually ring, so that's great. It would appear that the phone is fully fixed now. I fixed the cord issue that was making it completely dead, and now I've replaced this bad cap that was stopping it from ringing. So yeah, interesting little puzzle, interesting bit of fun. It's always fascinating to find out how something's failed and fixing it. At least for me anyway, that's just fascinating to me. And yeah, saved this from a landfill. That's great. Sad to think of how many of these might have ended up in the trash just from like a, you know, $1 cap or something. Yeah, anyway, but there we go. So if you have one of these or one similar to it and it's not ringing or it's not working at all, yeah, look into the cord being bad, or look into this cap. I don't know why this failed again. It could have been because of the aggressive way these leads were bent over, and maybe over time moisture got in and corroded it and it failed, or maybe it just, yeah, saw too many high voltage spikes or something on the line, and just broke down and failed and went sort of funny. I don't know. yeah, not sure really the failure mechanism of these things, but it has failed and obviously doesn't work anymore. I'm not worried too much about that other one being in there. I know it's quite old, but I mean, this thing's running off an optical router, fiber optic router. It's not going to see any any big transients or anything from lightning storms or anything at all. It's just powered directly from the router there, so there's not really much scope for the lines to pick up noise that much anymore. I guess. So yeah, I don't know, it should be fine. So I can put this into service now and use it. I like the fact it's got the speakerphone option, that's pretty cool. I haven't actually tested to see if the mic in here works, but I don't see why it wouldn't. Everything else seems to work, and the great thing is I don't need batteries in it to actually make it usable. So seeing as that's just a timer thing, it's like, well, I don't really care. It's not something that I'm worried about, so if I can just use it as is without batteries, that's totally fine by me. I'll probably just do that, to be honest. I don't need this feature really. But who knows? Again, if someone has a manual or a link to a manual or something that I could find out whether that's necessary, or how exactly the timer thing works, because it's a bit confusing as to how it actually functions. And again, I think this is another tactile switch here. These seem to be membrane ones because they're soft, but yeah, this one, and these two seem to be a bit dodgy, so I might have to replace those at some point. They seem to be jamming and being a bit touchy, so that's another thing, but that's pretty common. Those tactile switches just fail constantly. I've replaced a lot of them in all sorts of different equipment. But there we go, so that's fixed, it would appear. I just got to put all the rest of the screws back in, and then I can use it. So yeah, like I said, that was a fun puzzle. Fun to find out what was wrong and fix it, and hopefully some of the troubleshooting steps in this may help you solve your own problems with a telephone or something else. So yeah, hopefully that was interesting, hopefully that was useful, and I'll see you next time.